Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The most acidic CH or NH bond is the one whose conjugate base, carbanion or amide anion, is most stabilized by resonance or inductive effects. Moving on to the next step. CH on the carbon situated between two carbonyl groups, flanked by C is equal to O on both sides, i.e., a 1,3-decarbonyl or malonyl type active methene. HB, CH on a carbon alpha to 1 carbonyl group. HC, CH on a carbon alpha to a nitrogen, not adjacent to carbonyl. HD, CH on a carbon between two nitrogen atoms, hemiaminal type carbon. He, H on an NH adjacent to a carbonyl, amide NH, typically pK-17-25. Moving on to the next step. Removing Ha gives a carbanion stabilized by two flanking carbonyl groups simultaneously, analogous to malonate or diamine active methene. This is double resonance stabilization. The negative charge can be delocalized into both C is equal to O groups, forming a stable enolate on both sides. Removing HB gives a monoenolate stabilized by 1 carbonyl, pK-20 for simple ketone alpha-H. Removing HC gives a carbanion with no adjacent carbonyl stabilization, only weak inductive effect from distant nitrogen. Removing HD gives a carbanion between two N atoms. Nitrogen lone pairs can destabilize by electron donation, and there is no carbonyl to stabilize. He is an amide NH. Amide NH is less acidic than active methene between two carbonyls, amide pK-25 versus active methene between two carbonyls pK-13. And for the final step, active methene, between two carbonyls is the most acidic because the resulting carbanion is stabilized by conjugation with two carbonyl groups simultaneously, analogous to malonic ester with pK-13. All other positions lack this double resonance stabilization. HB, only single carbonyl stabilization, less acidic than Ha. HC, no carbonyl adjacent, least acidic CH, HD, between two N atoms, no carbonyl, not more acidic than Ha. He, NH, amide pK-25, less acidic than doubly activated methene. Therefore, the correct answer is A. Therefore, the correct answer is option A.